Okay, so hi guys, today we are gonna start with reactions of alkenes. Alkenes undergo addition reactions. The second organic family in all levels is alkenes, and its reaction will be addition reaction. We'll study about its addition reaction in all levels organic chemistry. So first is addition of hydrogen to alkenes. So when a hydrogen is added to alkene, hydrogen gas is added to alkene, it will react with alkene in the presence of nickel solid and 140 degrees Celsius temperature. These are the conditions, you need to memorize them, and what it will form? It will form alkane. Like alkene is CnH2n, this is its general formula, and hydrogen is added. When hydrogen is added to this general formula, H2 is added to this general formula, so two H's are added to this, so it will make CnH2n plus 2H plus, so CnH2n plus 2, so it will form CnH2n plus 2, so it will form alkane. CnH2n plus 2, it will form CnH2n plus 2, and CnH2n plus 2 is the general formula of alkane. So alkane reacts with hydrogen gas in the presence of nickel solid and 140 degrees Celsius. These are the conditions to form alkane. This reaction is used to manufacture margarine in the vegetable oil industries. This is its use. What it is used to manufacture margarine. Write down a balanced chemical equation when hydrogen gas is added to ethane. So here the alkene is ethane. So when a hydrogen gas is added to ethane, this is the structural formula of ethane. When it is added to ethane, so these HH bond, this HH bond is broken down, and one H attaches over here with this carbon, and the other H attaches over here with this carbon in the presence of these conditions. So one H, so it will have 3H here, and this carbon will also have now 3H. So what is formed? C2H6, and this is the general formula of ethane. So ethane plus hydrogen gas, it forms ethane. Now coming to more questions, as we have now, what we have done, the recent question is that ethane plus hydrogen gas forms ethane. So how do we write? We don't have to draw this entire structure to explain this to the examiner. We only have to write this equation, molecular formulas. C2H4 ethane plus hydrogen gas, H2 gas, and we have to write these conditions on the arrow. Nickel solid 140 degrees Celsius forms ethane gas. And now propane, if hydrogen is added to propane, this double bond will also be broken down. Remember this double bond, this one, not this one, this one will be broken down, as hydrogen is attached to the one hydrogen is attached to this carbon, and one hydrogen attaches to this carbon. The hydrogen atoms, both the hydrogen atoms will attach to those two carbon atoms which are bonded covalently, which are double covalently bonded. Okay, not this. These will not attach to this. It is already saturated. It has full number of hydrogens available bonded with it, so it will not bond any more hydrogens with it. So hydrogens will attach with these two carbon atoms in the presence of these conditions, and what is formed? This is propane. Propane is formed from propane in the when propane reacts with hydrogen gas in the presence of these conditions. Now coming to butane, this carbon double bond, carbon double bond will be broken down. Here HH bond, single covalent bond, will be broken down. One H attaches to this, the other one this, and these will not, as it has complete number of hydrogen attached with it. It is saturated carbon. These both are already saturated. So H will attach to these two carbon atoms, and it will form butane alkane. Butane is formed from butane. Now coming to this, and we write it like this: butane plus hydrogen gas, these conditions, and butane is formed. and now 1 2 3 4 5. This is now propane. Now if we take for example, what if the double bond is not on the last or the first carbon atoms, double bond is in between, is on the second or the third carbon atom. Here in case it is on second carbon atom, so what will happen in this situation? The hydrogens will always attach to those two carbon atoms which are double covalently bonded. So these are the carbon atoms double covalently bonded. This carbon double bond will break, and one hydrogen will attach to this carbon, the other hydrogen will attach to this carbon to form this. What is this? 1 2 3 4 5. Propane. Propane is formed from propane. Now coming to the second one, we are done with the idea, the first one, which was addition of hydrogen to alkenes. Now coming to the second one, which is addition of steam to alkenes. Steam is actually H2O. Steam is actually the vapor form of water, so we take H2O, but not in liquid form, we take it in gas form. So when alkene reacts with H2O gas under these conditions, what are the conditions? This is 300 degrees Celsius temperature, this is 70 atm pressure, this is pressure, and this is a catalyst, H3PO4 solid, in the solid form. This is a catalyst and this is temperature. Under these conditions, when alkene reacts with steam, it forms alkanol liquid, alkanol in liquid form. So for example, we take ethane, this is, and this is HOH. In this case we don't have HH, we have HOH. This is the structural formula of H2O. So in this case, like this, we can also write it like this. So in this case, here H will separate from this, will break away from this OH, and this bond between them, it will break down. This H is separated and this OH part is separated. This H part will attach to one of the carbon atoms in ethane, the one which are double bonded, and this OH will attach with the other one. Like if we attach this OH with this one and this H in this one, under these conditions, we are gonna have this carbon will have now 3H, so here CH3, and this carbon will have 2H and 1 OH, so C2H, CH2 and OH. So what is this structure formed? This is actually ethanol is formed. So when you react alkene with steam in these conditions, an alkanol is formed. In this case, ethene reacts with steam to form ethanol under these conditions. Ethene reacts with steam to form ethanol. Now propane with steam. Propane, this is another alkene and we will react it with steam. So here we go, C3H6, this is the double bond, it will break down. One H will attach to this, one H will attach to this, this H will attach to this carbon atom, this OH group will attach with this carbon atom. Nothing will attach with this carbon atom as it is already saturated and there is no double bond of this carbon atom. So when they will react under these conditions, this will be formed. What is this? 1 2 3, this is actually propanol. Propanol is formed from propane. Propanol is formed from propane when it reacts with steam. So these are actually addition reactions. As water is being added, these things, in previous case hydrogen was being added, H was added to this carbon and H was added to this carbon, and in this case steam is being added to this. How H is added to one carbon, the OH is added to other carbon. So these are called the addition reactions. Now we have some more examples here, like butane, we reacted with steam. So butane, when reacts with steam, H added to this carbon, OH added to this carbon, so it forms this structure, and this structure is butanol. So butanol is formed from butane when it reacts with steam. And what if in this case the carbon carbon double bond is not on the first carbon atom or not on the last, it is in between somewhere. So the carbons with the double bond, they will have these groups attached with them, like OH will attach to any, like if we take it, OH will attach to this, H will attach to this, H will attach to this. So this is the structure formed, and this structure 1 2 3 4 5 5, this is actually on the second one, so we call it pentan 2-ol. As you remember that OH is on second carbon, so we name it pentan 2-ol. Now write a balanced chemical equation when chlorine gas is added to ethane. This is a new reaction, but the same as the previous ones. This is the same, as it is also an addition reaction. So when as chlorine gas is being added, so when ClCl is being added to this ethane, it is as simple like we take hydrogen as we did hydrogen. One chlorine attaches to this, the other chlorine attaches to this carbon atom, and this structure is formed. Except for in that case we had when ethane is added to hydrogen, we had ethane. We will have ethane here, but with two chlorines attached, so we will call it di means two, chlorines, ethane, dichloroethane. This is ethane added to chlorine gas, dichloroethane is the product formed. This chlorine one, this was actually addition of halogens into alkanes. Previous reaction on last page was also this one. So alkene plus halogens, haloalkane is formed. Like in the previous case we did dichloroethane, so haloalkane is formed. Fluorine gas is added to propane. More examples. Fluorine gas is added to propane, this fluorine. Now instead of, as we have halogens are group 7, fluorine, chlorine, bromine, iodine, astatine. So here we add fluorine to propane. You know that these fluorine, chlorine, bromine, iodine and astatine, they are diatomic molecular compound. They are diatomic molecules, atoms. So what it means dimolecular? It means that they have 2 atoms each. Like F2 will have FF here, Cl2 will have, we have written on the last page, ClCl, Br2 will have Br, Bri, 2II and AT. So here we have FF. This FF single covalent bond will be broken down, and here carbon double bond will be broken down, and the same way as HH was added or HOH was added. So F1F will add to one carbon, the other F will add to the other, and here we will have difluoro, and same ethane is formed, but we'll have 2 fluoro attached with it, so we will call it difluoropropane. Propane added to fluorine forms difluoropropane. Addition of halo acid to alkanes, the fourth one. This is the fourth one. So this is the addition of halo acid. What are halo acids? Halo, same group 7 acids. Acids mean which have H plus ions when dissolved in water. So we just halo H, F, H, Cl, H, Br, H, I, H, AT. These are the halo acids: hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen acetate. So when halo acid is added to alkene, what actually happens? Haloalkane is formed. For example, hydrogen chloride is added to ethane. This is our ethane and this is hydrogen chloride. The HCl covalent bond here in this case will be broken down, and here carbon carbon double bond will be broken down. Same will happen. One H attaches to this H attaches to one of the carbon atoms, then the Cl will attach to the other carbon atom, and Cl is CH. So here in this case, same, alkane is formed. Alkane is formed, but here not to one chlorine is attached. So what we will call it, one mono means one chlorines attached with ethane. So monochloroethane. We name it monochloroethane. So ethane when reacts with hydrogen chloride, monochloroethane is formed as a product. Now the last example we have here is we add hydrogen fluoride to propane. So here is our propane, hydrogen fluoride is being added, HF single covalent bond will be broken down. Here carbon carbon double bond will be broken down, H is added to one of the carbon atoms, F is added to other carbon atoms. So this is formed, CF and H. Here alkane is formed but with one fluoro, not two, one fluorine attached with it. So we will name it one, mono means one fluoro attached with propane. So monofluoropropane, we name it monofluoropropane. This much is for this video. In next video you can see our topic. We will start with how to prepare alkanes in the lab or industries. As we have done the production of alkanes in labs or industries, now we will also do preparation of production of alkanes in the lab or industries. So till now, goodbye, and do not forget to subscribe, like and share, and goodbye.